Okay, so we are going to continue today with chapter 15. And I know that was, a whole long while ago. So let's kind of review what we've done so far for chapter 15. So I'm going to share my screen. Okay. Wait a minute. Let me just, it doesn't tell me what I'm actually sharing. All right, there we go. I wish there was a little more feedback from the, from Zoom because I can't see what I'm actually sharing. Like it would be nice if I had like a little window for sharing. All right. So last time we worked on this idea of a sensitivity analysis. So we were working with a project. Let me flip here too. Right. We were working with a project that had some assumptions. So we started with these base assumptions that we were going to buy some piece of equipment. It was going to cost us $240,000 for the equipment. Equipment and install. I forget what story we told. Maybe $200,000 for the equipment, $40,000 for the install. We assumed a volume of 5,000. Net revenues 80, 40, so forth, right? So we had all these assumptions over here, and then we built our little model. And we calculated the NPV, and we did that. So we did that for the base, and then we said, doing our sensitivity analysis. So remember, sensitivity analysis takes your model, right? So this base model, and it says we're going to hold everything constant except for one variable. So these are like all our variables over here. Well, not all of them are variables, but so we could say volume would be a key variable. And so this sheet, what we did was we said, all right, what if we vary the volume? And so we said, what if we assume that volume is off by 30%? And we calculated the NPV if the volume was off by 30%. And the way we did that was we said, all right, we're going to have volume be 30% of 5,000, right? 5,000 was the base. So we're going to have 30% off from 5,000. So we multiplied 5,000 times 1 plus minus 0.3, which gets us 70% of 5,000. And then we had, because we had built our model with volume assumptions built in, when we changed the volume, it automatically fed through our whole model, right? So volume impacts both revenues and supply costs, right? Because supply costs are a variable cost and they're based on volume. So that fed through, and so we said, all right, well, if we're off by 30%, then we said if we're off by 20%, and then we said if we're off by 10%, and what if our volume is, we understated our volume by 10%, and it really comes in at 110% of what we think. Well, how much better off would we be? And so we had basically an NPV for each of those. So we changed our model, holding everything constant except for volume, and we came up with the NPV based on changes in volume, right? And this is our sensitivity analysis for volume. And again, we only change when you're doing sensitivity analysis, you build your base case, and then you make changes to one variable, holding all the other variables constant. So we did volume, then we did the same thing with net revenue, right? And we said, okay, instead of changing the volume assumption, we're going to change the net revenue per visit assumption. And so we went from having a net revenue of 80 to 70% of 80, which is 56. And we said, how does that impact, right? And again, what the difference here was, we're not manipulating supply costs. We're only, because we're holding volume constant, we're only manipulating revenue, not supply. So supply winds up staying the same, and volume stays the same. But the impact on our model is through net revenue instead, right? And so we did six variations, both positive and negative, only varying the net revenue number, holding everything else constant, and we did a summary over here for net revenue. And then we did, we varied supplies, we varied salvage, and you could have chosen to vary overhead if you'd wanted to. You could have varied, can't vary depreciation, and you could have varied labor. One thing we could also have varied that we didn't really get into was our inflation assumptions. You could have varied inflation assumptions, like how sensitive are we to our inflation assumptions. So any of those could be varied. Okay, and then we summarized on this sheet, and we grabbed from our supplies sheet, we grabbed our supplies outcomes, we grabbed our net revenue outcomes and so forth, and we graphed all the outcomes over here. And what we're looking for, right, when we do sensitivity analysis, what we're looking for are the points, the variables that have the most significant impact on our model, right? And so that's the usefulness of sensitivity. Is you want to do the sensitivity analysis, and the purpose of the sensitivity analysis is to figure out where does our risk come in, and so you're looking for where in the model, which version of the model, right? Which part of the sensitivity analysis reveals where our profitability is most impacted by which variable. And so what we see is the net revenue variable, right, has the most dramatic impact. And we know it's the most dramatic impact because it has the steepest slope, right? When we were off by 30% for our net revenue, our NPV was down the most. And when we were up 30% for our net revenue, our NPV was up the most. So what this shows us is, holding everything else constant, the variable that has the most impact on our model is net revenue. So that's an important thing to know, right? So if you're starting to think about, all right, I've made this guess, right? I've got this model that I've built, and I'm making a projection about the future. If I'm wrong about, say, net salvage is this orange line, right? Very little impact, right? So our worst case scenario for salvage is we're off by 5,000. Our best case scenario for salvage is we're up by 5,000. It has very little impact on our overall model, right? We're able to just kind of, at this point, when we can see this kind of, when we can see this and visualize this, we can say, look, we just don't care that much about salvage. It's just not going to make that much difference. If we're wrong by 30% in either direction, it's just not going to have that much impact on the overall profitability of our estimates, right, of our project. But if we're wrong about net revenue, it's going to have a dramatic effect. And so, as a manager, the insight that this gives you is you've got to really pay close attention to the net revenue. And so, if you were, going beyond just the initial financials, and you were going to, launch this project, the thing you would be wanting to monitor most closely then would be net revenue, and you just really wouldn't worry that much about salvage. You could be wrong, you could be right. It didn't really matter that much. Just not going to have that much impact. And then followed that, it seems like volume had a big impact. And then supplies has a fairly significant impact, but we talked about last time we'd have to reverse it, right? Because it shows it going down. And I think what we found was it tracked with volume, I think was right. Let me see, we should be able to tell that real quick. Yeah, it's the opposite of volume. So if we inverted it, the impact from adjusting just supplies tracks with adjusting volume. So it's about as sensitive as volume. So, and that makes sense. because the two are linked. So what we're going to do now is we're going to go beyond the sensitivity analysis. So the difference between, and we're going to work on scenario analysis. So the difference between scenario analysis and sensitivity analysis is sensitivity analysis, you're manipulating one variable and holding everything else constant. With scenario analysis, you're going to choose several variables to manipulate at the same time. And you're going to come up with different scenarios. So we've been kind of doing this all along. We've been doing this, I think, even since not management, but Finance 1, where we've been talking about like a good outcome, a great outcome, and a bad outcome. And that's what we'll do today. We'll just do 3 variations. But you could have as many variations as you want. You could have a really, really bad outcome, and then a really bad outcome, and a bad outcome, and then a good outcome, and then a great outcome, and a really great outcome, and a really, really great outcome, right? You could do that. And that may be an exercise worth engaging in. And it just kind of depends on how realistic you think you can manipulate your assumptions. Because now what we want to get to with sensitivity analysis, we didn't really care about whether the assumptions were realistic or not. Right? That wasn't the point of sensitivity analysis. The point of sensitivity analysis is to find the variables that have the biggest impact on your model, right? And then the outcomes that come out of your model. With scenario analysis, so it wasn't like, is it realistic that you would be 30% off on your net revenue? That wasn't the point. It's not the point to say whether it's realistic that you might be minus 30% on net revenue and positive 30% or positive 30% on net revenue. The point was to find out how much impact does net revenue have on your outcomes, right? And then how much impact does volume have on your outcomes, and how much impact does salvage have on your outcomes? And you're testing along the way to see where do you need to pay attention. So that's the point of sensitivity analysis. We're going to move now into scenario analysis. And now with scenario analysis, now that we're armed with this information about sensitivity, that's one data point, one thing we're going to kind of take into consideration as to whether we want to pay attention to it or not. But more importantly, as we move into scenario analysis, now we want to be thinking about what are the realistic possible outcomes. Okay. So to do scenario analysis, we're gonna for today we're gonna come up with 3 scenarios. We'll have the kind of the standard we've been working with. We'll have a good expected kind of base case scenario, a bad scenario, and a great scenario. So to play along at home with me, what I'd like to do is rather than rebuilding our whole model again, which is why I just sent out this spreadsheet. You should have gotten a message from me about 20 minutes ago with this spreadsheet that I'm currently working with. Let me get back to sharing it. So what I'd like you to do is, if you don't have it open, go ahead and open it and do your best to follow along with me. Let's go to the volume sheet just so we're all starting from the same place. So click on volume. And then we're going to copy it. So you're going to click on it to highlight, volume sheet down here at the bottom, right? And then we're going to right click, choose move or copy. We're going to create a copy, and let's stick it here and tell it to move it to the end. So that way, and so you should now have a brand new sheet called volume parentheses 2. And it should look just like the volume sheet. And what we're going to do is we'll double click on the tab and we'll rename this scenario. Okay. And so what we have is the sheet that we worked with to calculate scenario. We're not going to need all the different cases this time. So let's take, and we're going to build a couple of, we're going to build our scenarios. So this will be our base case or our good, right? We can kind of just call it good, right? This will be our good case. So we don't have to do anything with this one. We're going to assume this is kind of the starting point. I'm going to delete that. I'm going to clear it. And so what do we want to assume is this will be our bad case, right? So we know that net revenue, we're really sensitive to net revenue. We know we're sensitive to supplies. We're probably sensitive to labor. We didn't actually test for labor. So let's now assume, and we're going to make this up, right? So just kind of what I'm telling you with scenario analysis is you want to be working with realistic expectations and probabilities. And so what you want to think about is, all right, if this was real world, you'd be wanting to think about what are the kind of worst case scenario situations that are realistic, not like, oh, I don't know, there'd be some crazy disease that would break out in China and come over to the United States and make us all stay home for unknown periods of time, right? That's kind of a way out possibility that nobody could actually plan for. So we want to plan for something that's kind of is not a hopefully like once in 100 years thing, but more like what's a thing that could happen, every 5 years, right? So you don't want to have like this crazy scenario where volume, worst case scenario, well, volume goes to zero because we all have to stay home, which is in fact something that folks are, some facilities are dealing with right now. What we want to assume is, all right, in a more realistic bad scenario. So something that might happen to us once every 5 to 10 years. So why don't we assume that we have kind of a several things go bad for us. Let's assume that volume is off by, say, 20%. And in fact, you know what, maybe we could just do that. We'll assume we'll just use 20% as our bad scenario for a couple of things. So first, we'll make our volume go down by 20%. So I'm going to multiply this times 1 minus 0.2. So I'm going to take volume is going to be at 80%. And then I'm also, to make this even worse, I'm going to make revenue go down by, say, 20% as well. So I'll take my revenue times 1 minus 0.2, right? And then, you know what, maybe I'll jack up labor costs by 20%. Making this pretty bad. And again, I'm being arbitrary because we are working in an academic environment. Oh, no, sorry. In this case, it's an expense, so I actually want it to go up by 20%. So I want to multiply the labor cost by 1 plus 0.2. Right, so my volume is going to go down. In my worst case scenario, my volume is going to drop to 4,000. My reimbursement per visit is going to drop from 80 to 64. Supplies will stay the same. Labor is going to be 20% more expensive. And you can see, because I've got this set up in my model, it fed right through, right? So this is going to be our bad scenario, right? So highlight that just to remind us. Bad scenario, everything's going to be off by 20. Well, not everything, but the three things are going to be off by 20%. Volume, net revenue, and labor. All right, everybody with me? Anybody not with me? Let me just send me a text or shout out. We're doing roughly the same thing we did last time. All right, I'll post this after. So if you wind up getting completely lost, I'll post this after, and you'll be able to look at the sheet. All right. So what impact does that have? Well, now we've got a NPV of minus 321, which is pretty bad. So let's go ahead, and I'm going to copy these cells that I changed. Right. So I'm going to copy from the 17 A17 down to B22. Right. I'm going to highlight that, and then I'm going to hit Control C to copy. Hey, what are you doing? Control C to copy, and I'm going to go down here and I've got to paste it here because I moved it up. So if you're with me, you want to copy that space, copy those cells, and then paste them in right here. Now, we're going to make this our great scenario. And I'm going to make this minus 0.2, right? And this just basically mirrors the projections I had up above, right? So because I had built those formulas up above, I just copied the formulas down, and I'm changing the input from plus 0.2 to minus 0.2, right? And it's making, so this is now 1 minus 0.2. So I'm getting, my great scenario is I actually get 20% more volume instead of 20% less volume. My net revenue is up by 20% rather than down by 20%. My labor is actually lower by 20%, right? So I'm just doing this kind of a convenience. And again, we're in an academic environment where we're just making stuff up. If you were in the real world, you would want to have a serious meeting with the people who run this project, right? And you would sit down with them, and you would have built the original model together, the good model, right? You would have done your sensitivity analysis, and you would have come back to them and said, hey, the pain points in our model are, it looks like volume, net revenue, and supplies. All the other stuff, doesn't matter what happens with them. Well, though we hadn't worked labor. So, what's really matters, it appears to us, is where we want to really be careful is around our assumptions about volume, our cost per visit, right, in terms of supplies, and our revenues per visit. So when we go to build the scenario analysis, those are the ones we want to take the most time thinking through and trying to come up with realistic, worst case scenarios, best case scenarios. I'm just kind of being arbitrary because the whole thing is made up anyway, right? But if you were really doing this as an analyst, supporting a department, you would want to talk with them about, all right, well, what have we seen in the past? What was our worst case scenarios? What were our best case scenarios? When you had a really great year, what did it look like? And so now we've got 3 years, right? We've got our base good case, we've got our bad case, and we've got our great case. Now, we've got a whole bunch of other stuff here that I don't want anymore. So I'm just going to go ahead and delete it all. So I'm just going to highlight all that and hit delete, right, just to neaten up my sheet. Right. So now all I have left on this sheet are the 3 cases: the base case, the good case, the bad case, and the great case. And if I go over here to the right, you can see I've got a bunch of stuff missing. So I'm going to clean this up a little bit. So I'm going to rename this scenario. Right. I'm trying to take advantage of the work I've already done. This is the bad case, This is the great case, and then these are blanks. So I'm just going to delete it and delete this. Just kind of neaten it up a little bit. And in fact, maybe what we could do is just, I'm going to highlight this and drag it down. There. So now that's kind of pretty. The base or good case, right? So these are all drawing, right? So this is drawing from E16, which is over here, right? We did that, you know, this is all stuff we've done before. The bad case is E33, which is, you know, this one here, right? And then the great case goes to E50, which is down here, right? So we're all lined up. So how are we doing? Were you able to find? I know I just did a couple of edits that maybe you guys don't aren't familiar with how to do. But I would like it if everybody could kind of have something that looks like this, because the next steps, it'll be easier if we're all together on it. Does anybody need any help? All right. Nobody's coming online saying they need help. So I'm going to assume you have something that looks like that. So what we now want to do is kind of what we've been doing. We've done in a couple of chapters. We want to get our expected NPV. Right. So the question becomes, what's, you know, in order to get the expected NPV or ENPV, right? Our expected NPV. I'll just go with the. What do we need in order to what do we need to decide about in order to get our expected NPV? What other data? What other assumptions do we need to make in order to get our expected NPV? What other data do we need? So we've done expectations before. Probability. Good. Thank you, Ariana. All right. So we need to know, right? We've got these three scenarios. What we need to know is how likely are they, right? So we're going to make up a probability. And again, this is where there's a lot of art to this. We're just making it up, right? Because we're in an academic environment and this thing doesn't actually exist and never will. But in the real world, if you were going to use this technique, you would have to kind of come up with an expectation about, okay, that bad scenario is pretty bad. You know, how often do we think that'll come about? What probability do we think, you know, looking into the next year, how likely is it that we're going to see that bad scenario? Let's assume that that bad scenario has a 20% probability. And again, we're just making that up here, right? Just between us. But in the real world, you still have to do it, right? And there's nobody that's going to tell you how it, you know, what it actually is, right? Because nobody can actually know. And there's a variety of techniques that you could engage in and be a little more advanced in this class. But you know, you typically look at your historical outcomes and you'd make some estimates. And then let's just say, you know, of course, the balance has to be 1. So let's say that there's a 30% chance of a great outcome. So then what would we do? Oh, and this would be, this would just be NPV. Volume isn't relevant. So I want to get expected NPV. I'm going to do what? Yeah, good. Thank you, Ariana. So I'm going to multiply the probability times the NPV for each. So I'll take equals 0.2 times the bad. And now I've got N4 times M4. So I can just copy that down. It's too big of a number. I don't need it to be that big. There we go. And then I'm going to sum those. So my expected NPV from this project, from this, based on our scenario analysis, would be 174,000. So if we have an expected NPV of 174,000, is this project a go or a no-go, just from an NPV analysis perspective? Good, go, right? Because what's the rule? Good. You want to have an NPV greater than 0. All right. Okay, so we've got NPV. And so that gives us kind of our expected outcome, but it doesn't tell us, how risky is this to us? So how do we measure risk? We want to calculate what? Good. We're going to calculate our variance, and then we're ultimately going to calculate our standard deviation. Okay, so let's get our, we'll calculate our variance first. Let's see, what's the easiest way to do this? Probably to create a new column over here that doesn't actually mean anything, but we'll do the variance calculations and then we'll just add it all up. So the variance calculation is going to be the probability times the outcome minus the expected outcome, right? And I'm going to go ahead and lock that because I'll be able to just copy this formula down, squared. Okay, so when I copy this down, it'll N4, right? The probability will, if I copy it down to this next cell, N4 will become N5, which is 0.5. M4 will become M5, which is the expected NPV for the base case. And then O8, because I've locked it, will stay referring to the expectation, right? And then raised to the second power. Well, nothing happens there. So I'm going to just copy those down, right? And so the variance becomes the sum of these things, which is a really big number. And then standard deviation is just the square root of this really big number, right? So we'll say equals this raised to, and to take square root, you just raise it to the 0.5. So we've got a really big standard deviation, 337, right? So if we were going to graph that, we were going to graph that. Let me see. Get my other camera up. I didn't have it up. Just use this for a second. right? We would have our expected outcome would be 174,000, right? And then plus or minus one standard deviation. So let's see, plus one standard deviation would be this plus would be the expectation plus 337. So that'd be 512. And then this plus this would be, and then two standard deviations. So this is plus one standard deviation plus two standard deviations would be 849, right? And then minus one standard deviation. Sorry, let me do this. Would be minus 163. And then minus, so that's minus one standard deviation, minus two standard deviations would be minus 501, right? So what's significant about this? We would expect to have, you know, roughly 96% of our outcomes, and as I drew this badly, the curve badly, it should be a nice even point here, but basically with this very large standard deviation of, 337,000, right? We've got an expectation of 174, but we're 96% certain that it'll be somewhere between minus 500,000 and plus 850,000, which is a pretty wide outcome. So there's not a lot of, if the projections we just did are accurate, there's not, this is a pretty wild process with a lot of possibilities. So we would have to be, the main question as an investor, remember we talked about being risk averse. The main issue, right, is for most investors is we don't want to lose money, right? So what's the chance that we'll lose money? And we could, that's if we were doing a more advanced class, we'd talk about, calculating the chance that you're going to lose money. But, kind of, for this chapter to think about what we've just done is we made a baseline. This is our base, right? Our base projection was going to be 174. We then made a projection about our good scenarios and our bad scenario, and we used that to calculate the variance that's associated with this project. And what we have seen is this project's got a lot of variance in it, and so we might be a little concerned about the safety of doing this project. But from let me switch. Right, so we might be a little concerned about the safety of this project, but from a strictly just from a demo perspective, we're doing, we're just following the steps for now. But that said, right, so again, when you do a project like this, if you're going to do an evaluation like this, you want to be realistic about all the assumptions that you're building in. And you want to take some time because maybe the assumptions that went into the bad assumption are just too bad, right? And so they give too extreme of an example, and so it's tilting us too far to the negative. Or maybe our great is too great, or maybe they're both just too wild, or maybe the probabilities are off, and all those things would change, right? So the beautiful thing about our projections is when you build this model properly is you could say, if we've built it this way, we can say is, all right, maybe it's not really a 20% chance of going bad. Maybe it's a 10% chance, and maybe there's a 60% chance of the baseline being good. How does that affect both my expected NPV and my standard deviation? And so the great thing about Excel and building models like this is that you can very quickly, if you've built the model properly, you can very quickly adjust your assumptions and play with them in real time. You know, what if the grade is really only 0.2, right? And this is really like 0.7. Well, now we've got, you know, a lower NPV, but also a lower standard deviation. So these are, you know, so this is how we play around with this kind of analysis. And then we could go back potentially and make changes to our assumptions here. And I'm not going to, you know, well, I guess I could. Like I could say, well, you know what, those bad assumptions being 20% off, maybe that's too extreme. Maybe it's just 10%. So since we built it that way, right, with the formulas referencing back to that one cell, we can change that one cell and we can go back over here and see what the impact was. Well, the impact, you know, if we reduce the bad scenario, the impact brings that bad outcome way down to, you know, to minus 124 instead of whatever it was. Sorry, I'm looking at the wrong one. And then that brings up our expected NPV and reduces our standard deviation from 337 to you know, 232. So that's, you know, that's the advantage. Where did we have 0.2 originally and 0.5 and 0.3? I'll just reset all that. And then we head over here, 0.2. Okay. So scenario analysis. We want to come up with, so kind of to summarize with scenario analysis, we want to come up with the 3 scenarios or more, right? You could have 4 or 5, however many you want to have, and not so much want as how many would be appropriate. And you've got to think through that process. And I'll tell you, you know, I work with different leaders and there is no like single book answer that you can memorize on this. This is art, right? This is where you have to kind of, as an analyst, use your experience and your knowledge, both about the technical pieces of what we're doing here, as well as the organization itself, to come up with you know, more meaningful projections. So maybe 3 scenarios is not the right choice to make. Maybe it'd be more like 5, you know, would be a better one to give you a more granularity. But again, you're kind of, you know, it's still art, because what goes into the scenarios, right, is still your judgment. There's a kind of, you know, famous saying in computer engineering, and I use it all the time when I talk about this kind of work, is, you know, garbage in, garbage out, right? So these are all, you know, all this technical stuff is all, you know, it's correct, but it's only as good as the stuff that we put into it. So, you know, if our assumptions that we use to build these scenarios, to build the model to begin with, right? If the assumptions we use to build our base model are garbage, then we're gonna, you know, do all the NPV correctly and do the calculating the variance and the standard deviation correctly. It all doesn't matter, because if you put garbage in, you're gonna get garbage out, right? The math just, you know, the math just crunches through it. It doesn't care whether you're giving it good or bad stuff, right? And so, and then the assumptions here about, you know, is 20% the right thing? Should we have a 20% volume variance but only a 10% net revenue variance? I mean, we could change all those scenarios. You know, you could change all those things. It doesn't have to be 20% down the line, right? You can change all those things, and you know, it just depends on what you, based on your professional judgment, would be the appropriate things to put in, and then you still could be wrong, right? Because you're trying to look into the future, and nobody can actually do that. Okay, so that's an example of scenario analysis. So you've got a couple of problems in the text that you'll have a chance to practice that. So questions on scenario analysis versus sensitivity analysis, because we are just kind of boogieing through this chapter. I've got a couple more things to show you. And we may just go ahead and move on to chapter 18 next time. Everybody's grooving. Everybody's following. You all have the same thing sitting on your desktop. Okay. All I see are black screens with people's names on them. So I can't tell if you're like, sitting there saying, I have no idea what you've just done. Okay. I got a smiley face from somebody, so that's good. Okay. So I'm going to assume silence and smiley faces means that we're good. Okay. So let's, I'm going to save that. All right. So the next thing I want to show you and talk a little bit about is project risk adjustment. So project risk, sorry, one more thing. Then we also might want to still consider the coefficient of variation, right? Or CV. We've done this already. So the CV is just you divide your risk by your expected return. And so the coefficient of variation for this project is 1.94. So what that would allow this this company, let's say this is a company and they're evaluating this project, and there might be 5 other projects that you've got to pick between. So, maybe we could buy this one piece of equipment, or we could buy a different piece of equipment for a different service line, or we could start a different service line. And so we're trying to make projections based on our knowledge of our organization, and we are comparing the possible outcomes. Now, when we look at the amount of risk involved in this one, so this is a coefficient of variation is a risk to return ratio, right? It is, so it tells you your relative risk, and so you want a smaller number if possible, right? So the bigger the coefficient of variation is, the riskier the project is. So with a coefficient of variation of 1.94, maybe the average risk of projects for this company is actually, the average coefficient of variation for this company is, say, 1, right? So the average coefficient of variation for this company is 1, and this project comes in with a coefficient of variation of 1.94. Is this project more risky or less risky than the average project for this company? So the average CV average is 1.0, right? This one has a 1.94. So is this project more risky or less risky than the company average? Good. Okay. Everybody's with me. All right. So if that's the case, then the company might actually want to adjust the discount rate that it's applying. Remember, we talked about discount rates, right? We talked about where does an interest rate come from? Well, there's a whole bunch of risk factors built into a discount rate. And so in this case, we might say, you know what? We have the expected NPV of 174. That was built on what goes into calculating an NPV. Well, you need to know. You put it over here. Discount rate. Yeah, corporate cost of capital. Right. We assumed that the corporate cost of capital would be 10%. Did I hard code that in? Nope. So we assumed that the corporate cost of capital would be 10%. But the corporate cost of capital of 10% is appropriate for if this firm's corporate cost of capital is 10%, then using the 10% corporate cost of capital is only appropriate for projects that have risk about the same as the firm's average risk profile. So if we're saying that this firm typically has a CV of about 1, and this project's got a CV of about 1.94, what we're saying is this project is a lot riskier than the typical project that this firm undertakes. If that's the case, then it wouldn't be appropriate to use the firm's corporate cost of capital. What we'd want to do is increase the discount rate that we're going to apply to this project to decide whether we should do it or not. And the reason we're going to increase the corporate cost of capital is we're going to increase the hurdle, right? Hence the hurdle rate. We're going to increase the hurdle that this project has to overcome in order for us to do it, because it is riskier. So even though it comes up with a positive NPV, maybe that hurdle rate is too low. So let's assume for the moment that this firm imposes a 3% penalty on risky projects. If this firm imposes a 3% penalty on risky projects, then the appropriate discount rate would not be 0.1 or 10%. It would actually be 13%. And what happens when we increase the corporate cost of capital from 10%, or in this case, it's no longer the corporate cost of capital, it's the adjusted corporate cost of capital, from 10 to 13? Well, maybe you didn't see it, but the NPV dropped. Right, I'll go back to 0.1. Right, it was 99,000, almost 100,000. If we raise the hurdle rate to 13%, then the NPV drops to 77,000 because we're now requiring this project to return more. Now, in order for that to be fully reflected over here, right, it's now, because we've done our nice modeling and everything is connected, the NPV base has been adjusted downwards to 77. We need to go and paste this into our other 3 because we didn't change it. So we'll just change them now to 13 and 13. And now with a 13% discount rate, the NPV, the expected NPV, is still positive. But it is lower than it was. The standard deviation is lower than it was. Right, it was 377, I think, if I remember correctly. But notice even though the standard deviation went down, as did the expected NPV, the expected NPV went down more than the standard deviation went down, and so the coefficient of variation actually goes up even more. So it is commonplace for firms to adjust to have a project-specific hurdle rate that is based on the corporate cost of capital or the corporate hurdle rate, and then to adjust the hurdle rate applied to the project based on the riskiness of the project itself. So in this case, we raised the corporate cost of capital. If we had said, you know what, this thing is actually, and you know, the numbers we're using don't show that. But you know, let's change the assumptions here. What if the corporate cost of capital, the average cost of, let me go back. I'm going to reset these to 0.1. And you know what, I'm going to save myself some time, and I'm going to make this, I'm going to link these together. There, now I can change them all at once. So the original coefficient of variation was 0.194. What if this firm had, say, like a, you know, the average for the firm was a 3? Well, in this case, this project would actually be relatively safe. It would be a lower risk project. And so in that case, the CFO would say, hey, this is a lower risk project than we normally undertake. We'll allow you to apply a lower hurdle rate to this project because we think it's, you know, it's not going to be as risky. So instead of adding 0.3, you know, 0.03 or 3% to the corporate cost of capital and then evaluating the outcomes of the project, we might subtract 0.03, so to make the hurdle rate 7%. And so you can see when I reduce the hurdle rate from 10% to 7%, the NPV jumps from 99,000 to 124,000. The bad is 326, and so I built in, now it's adjusting automatically. And so we go back over here. We can see that our expected NPV is higher now, right? Because we were discounting our future cash flows at a lower hurdle rate, and then the standard deviation is lower as well, and our coefficient of variation is actually down from, what was it, 1.97 to 1.77, right? So it is common practice for firms to use their corporate cost of capital as a baseline, and for them to look at a project and make a judgment about its risk relative to the corporate riskiness, and decide that a lower hurdle rate will be used on this project, right? So in this case, we're showing the results of the lower hurdle rate. And then I go back, I can reset it to 0.1. Okay, and so we're back to where we were, 1.94. All right, save that. Okay, so you have, you know, you can have a firm right? You can have a firm that has, say, a overall corporate cost of capital of, say, 10%. That's what we've been playing with. And then they can have a policy of adjusting the cost of capital for a particular project up or down, depending on the risk of the project. Now, it is also possible that, let me see, how do I want to do this? I'll just do it in Excel. People are leaving. We were up to 38, and now we're down to 31. Is there something hot going on in the... All right. So you might have your corporate cost of capital might be, say, 10%, right? And then this is maybe a large company, like, let's say, like Partners, right? Partners is a really big organization. So Partners is the parent company. I know most of you probably know this, but Partners is the parent company for Boston Children's, Mass General, Brigham, and then a bunch of hospitals, Wentworth Douglas, for example, right, and a bunch of kind of other little hospitals around, smaller, they're not little, smaller community hospitals around the Boston area. So, this could be the, partners corporate cost of capital might be 10%. It's probably lower than that, but it might be 10%. And partners might have their main divisions might be like, say, Mass General, right? Maybe, about as risky as the parent. So they may have, so Mass General would be a division of the corporation. So Mass General might have a division corporate cost of capital. That is a modification of the parent partner's corporate cost of capital. And if we assume that Mass Gen is about as risky as the overall partners, then they would probably have a cost of capital, or they would have a cost of capital equal to the parent, right? But Mass Gen could engage in, just like we did before, could engage in different projects. So Mass Gen could say, for high-risk projects, we add 2% to our corporate cost of capital. So we take corporate cost of capital plus 2, right? For average risk, they're just equal to the corporate cost of capital. And then for low risk, we subtract 2. So, right? So we have partners, the parent company, and its corporate cost of capital is 10%. Then we have Mass Gen, which is a division of partners, and it has a risk that is equal to partners, on an average risk of its projects equal to partners. So it has the same risk as partners does. And then we have, Mass Gen runs its own projects. Let's do this. Right. And so Mass Gen, if Mass Gen has a high risk project, it adds 2 percentage points to the hurdle rate that it applies to high risk. Its average risk projects get the same risk level as the parent division's cost of capital, and then the low risk projects get a reduced corporate cost of capital. So let's say that's Mass Gen. Let's assume that they have, partners has a low risk division. Let's say that's the rehab division, right? And the rehab division has a corporate cost of capital, and it's lower risk than the hospitals, the acute care hospital side. So maybe its corporate cost of capital starts at 2% lower than the partner's corporate cost of capital. And then the rehab division has projects which it assigns hurdle rates. And so projects that are happening within the rehab division that have the same level of risk as the rehab division get the same level of hurdle rate. Projects that have a higher risk than the rehab division's average get a higher hurdle rate, and projects that are even lower risk than the low risk division, right, get a even lower hurdle rate. And as you might imagine, now we have the high risk division, which maybe is the research arm, right, of of Partners, and Partners has a research arm where they're trying to come up with a COVID vaccine, or they're trying to develop a new kind of ventilator, and things like that. And actually what Partners does is they may work with their doctors who are all doing research, and they come up with this clever scientific breakthrough. They will patent it, and then they will attempt to sell that project. They'll create a joint venture company with the researcher and partners, and they go in together to sell the product. And so a lot of the one of the benefits of being part of Partners is, if you're a researcher, is they're very eager to help you monetize things that you invent. And UNH actually has this. If you guys go over to, if you go over to Hop and Grind, the what is it called? The Innovation something, UNH Innovation Center, I forget the name of it, is over, in that parking lot with Hop and Grind. And that's actually what that UNH division does, is they work with researchers, particularly the hard science folks, who are, working on some new chemical process, or or their computer people are, making some new kind of motherboard or something like that, right? They will work with the UNH researcher to patent the application, and then bring it to market. And then UNH makes, UNH takes a cut, takes an ownership stake in the product, but also the inventor, maybe it's some professor over in chemical engineering, right, takes an ownership stake as well, and then UNH and the professor profit. So Partners does this, but this is clearly a higher risk realm over there, right? So in this case, they would have the corporate cost of capital, and they would have some additional risk. So the baseline risk for the research division would be higher than the baseline risk for the corporation, because all of their projects, on average, are riskier. And then within the research division, you would have high risk projects, average risk projects, and low risk projects, right? And so it's possible to have, and this is a pretty ordinary structure. You would have a kind of parent, and then divisions, right? And this is the high risk, average risk, low risk, not risk, right? Right. And so the high risk would start with the corporate cost of capital and adjust upwards. And then the projects that happen within the high risk division would have their own adjustments off of the division's base division cost of capital. Okay. So that's an example of how risk adjustment can be done for the divisions, right? So for a corporation with divisions, and the divisions have some sort of risk profile that maybe is different from the parent. Okay, so what we had looked at initially was kind of looking at as if this like MGH, right? So a parent or a corporation, and then it might have adjustments for projects. This variation kind of takes that out to another level and says, all right, we have a parent company, divisions with unique risk profiles, and then within those divisions, we would have project risks. All right. Let's see. We have like 8 minutes left. All right, one last thing. I'll name this division. CC, so that's my division example. So evaluating costs. All right, so evaluating costs. If we have costs happening in the future, and we're trying to evaluate them, let's say we're going to have, we're looking at saving money, and you know what? I'm going to stop here. So we'll finish this last point next time. I just don't want to run out of time while I'm doing it and rush. We'll finish up this last point from chapter 15 and move on to chapter 18 next time. Homework won't be due next time. Homework can be due a week from today. So chapter 15 homework will be due a week from today. We'll wrap, but just so you're all with me, we'll wrap chapter 15 this time, chapter 15 on Wednesday, and then move on to chapter 18 on Wednesday. That'll put us hopefully a little bit ahead. Chapter 18's got a lot of stuff in it. So give me a little more time to work with chapter 18. Worst case scenario, we use up the extra time for chapter 18. Okay, any questions for me on what we've done today? All right, I don't see any. I'm going to hang out for a few minutes until you're all gone, but I will see you back in a little over an hour.